With growing concerns about global warming, industries around the world are being pushed to reduce their energy consumption and reduce their carbon emissions to meet environmental legislation.
Stand back.
For all industries, the overall drive for efficiency, to improve production and reduce energy consumption, has become an imperative. The dilemma is, how does a company become more efficient without massive investment, change, and disruption of business?
Picking up this steam.
But if you are a steam user, then help is at hand. There is a simple, proven and reliable device which is rapidly establishing itself as the means of improving efficiency and output, reducing maintenance and energy bills across a range of industries. It's the GEM steam trap.
Big headache removed on the energy front.
The steam efficiency side and the cost savings, especially the cost savings, they've been quite phenomenal really.
We found an 11% saving straight away.
Reliability's been fantastic.
From a maintenance point of view, we do not lose any downtime.
As far as breakdowns go, we just don't touch the traps. I mean, once they're in, that's it. We've never touched them since.
And of course, there's no spare parts, no running around checking steam traps like we used to. And it's a much improved system. So we can say they definitely work.
It's estimated that steam loss alone costs British industry £3 billion a year. In 1995, chartered engineer Tim Gardner, concerned by the steam wastage through conventional steam traps, looked at developing a new steam trap that would overcome the problems inherent in mechanical traps. His solution was the revolutionary GEM condensate return system, featuring the GEM steam trap with no moving parts. Tim Gardner's revolutionary design was a development of the orifice plate traps used by the US Navy in the 1960s. They were more efficient and reliable than mechanical traps because they had one crucial feature: no moving parts. It's the mechanisms in most steam traps that cause problems for steam users.
These are interesting because they're like your cistern on your toilet. It's like a ball cock operation, and of course there's the ball, but there's so many mechanical bits about this, and they all got rusted up, and when you pull them apart they were all full of mud and looked rather horrible. The other thing about these mechanical steam traps is all the various orifices in them. Once the steam had gotten going in the wrong direction through the minutest of holes, it's a powerful agent steam. It drills holes in the cast iron like that. Hole there shouldn't be there. That bit in the middle should be half an inch thick, and it's actually eating it all away. So this actually must have been no good at all, you know. Here again, you might as well have just had a straight pipe. All the water and the steam still carried on its journey. This one is the GEM steam trap, which of course, one of its greatest features is there's no moving parts. There's nothing that gets stuck or worn out, you see, and there's no way the steam can get straight through it. And that's really the secret of it all.
So how does a GEM trap work? There's a flash demonstration available on the GEM website. The GEM trap works by using the difference in density between steam and condensate. Steam is 1,000 times less dense than condensate. So at the entrance to the trap's orifice, the low-density steam is literally squeezed out of the condensate. The high-density, slow-moving condensate is then preferentially discharged through the orifice, trapping low-density steam behind it. The GEM trap has no moving parts, so there are no moving parts to jam, wear out, or corrode. To prove a trap's effectiveness to get rid of condensate or water without losing precious steam, there are some simple scientific tests.
Basically, this is what's known as a bucket test. And of course, it proves without a shadow of a doubt the amount of condensate and steam that comes out of any steam trap. All you've got to do is, at the end of the day, weigh the contents of the bucket, and the more that comes out, the more inefficient the thing is. This basically is the same test as the other one, but it's with a mechanical steam trap. And of course, we've had to actually get a bigger bucket because of the violence that it released its condensate and steam.
As well as being efficient, the GEM system is also able to self-regulate to varying conditions within a steam system due to its unique patented Venturi design. When the condensate gets up to steam temperature, 15% of it is re-evaporated as flash steam as it exits from the orifice. This flash steam puts a local back pressure on the orifice, reducing its capacity. Hence the trap's ability to self-regulate and work effectively over varying loads. As Fred explains, this flash steam can often be confused with live steam.
If it were steam direct from the system, it would be coming out and we wouldn't be able to see it, you know. It's the water that's accumulated the other side of the small hole, flashing into steam as it comes through, you see. And so there isn't really any great waste.
The GEM trap's performance under varying conditions or varying loads was analysed by the engineering researchers at Queen's University in Belfast. The research team, led by Dr. Gavin Walker, reported,
measurement of the operational efficiency of both the GEM Venturi trap and new conventional traps over varying condensate loads show that the GEM trap is more efficient than both the mechanical and thermostatic traps in terms of discharging condensate with minimum steam losses.
And the report concluded,
the GEM trap proved to have better efficiency than the float and thermostatic trap in modulating over varying pressures.
The efficiency of the GEM trap has also been independently researched by the UK government's Best Practice programme, which found that GEM traps gave 19% steam savings compared with mechanical traps at Withington Hospital Laundry in Manchester. So trap failure, repairs, spare parts and testing are all a thing of the past.
I'm Alex Thorpe of Cadbury Treacle Bassett Sheffield. I am currently employed as GUM Engineering Manager. My team look after 63 stoves, all of which have got GEM steam traps as the means of venting condensate. The steam traps have been installed since 1996. We have not changed any traps, so they're all working as designed. We typically produce 500 tonnes per week of product, all of which goes through our stoves. The project was dealt with jointly. GEM did the necessary testing for us to establish the condensate loads. From that, the bore size of the GEM traps was obtained and nothing's changed since. It's delivered what it said it would deliver. From a maintenance point of view, we do not lose any downtime with production waiting for stoves. The stoves are available as and when required, and so that's another plus for using GEM traps, with them being virtually maintenance free. Just so long as we keep on top of cleaning the filters and filter strainer units, and we do that annually.
The efficiency of the GEM systems enable users to achieve permanent energy savings of between 11 and 55%. This has helped customers meet their climate change levy targets and other environmental obligations. And of course, reduce energy costs and increase profit.
from the steam efficiency side and the cost savings, especially the cost savings, they've been quite phenomenal really. We can run more efficiently, plus we have an agreement with a power station that we get charged for a certain level under our condensate returns, so it's double-edged really. The more we return, the more we save.
Multinationals like chemical giant Clariant, who installed 73 traps across a variety of applications, have seen operational improvements as well as savings.
Overall, it's calculated that the saving in boiler fuel cost resulting from the more efficient use of steam and the reduction in make-up water amounts to £25,000 per year. Based on energy and water saving alone, the simple payback on the initial capital investment of £14,723 is just over 7 months.
We found an 11% saving straight away.
Tate & Lyle also reported improvements beyond their expectations, including improved process stability.
The overall yield from the plant increased by 15%, with no change in the steam consumption.
The traps typically pay for themselves in under 2 years, and usually between 1 month and a year. The GEM condensate return system is a proven permanent solution to the inherent problems of steam traps. But don't just take our word for it. Some of the world's leading companies in the chemical, pharmaceutical, rubber, food and beverage industries, as well as hospitals, laundries, paper and textile mills, oil refineries and power stations and many, many more sectors have converted to GEM traps.
You know, it's so simple, and you know, it's took like best part of 200 years of steam trap construction to actually come down to something that's as simple as this that actually works.